Proprioception, also known as proprioceptors, are specialized sensory receptors that are located within joints, muscles, and tendons. Because their receptors are so sensitive, they are sensitive to pressure and tension, and they relay information concerning muscle dynamics to the subconscious and conscious parts of the central nervous system. The brain provides information about certain kinesthetic sense or about conscious appreciation of the position of the body parts. The proprioception information is processed at the subconscious level, so we don't have to dedicate conscious activity towards maintaining posture or position of body parts. Muscle spindles are a type of proprioceptor. They're consisted of muscle fibers that are enclosed in connective sheets of connective tissue. These modified fibers are called intrafusal fibers, and they run parallel with extrafusal fibers, which are considered the normal fibers. The muscle fibers provide information about muscle length and the rate of change in length. They are able to provide the impulse from the neuron to the spinal cord, which results into the activation. The spindles are able to indicate how much of a load increase to the muscle that needs to be overcome the resistance. So once a load increases, the resistance will also increase. Muscle spindles, muscles that perform a more precise movement will have more spindles per unit to be able to exact control of their contraction. So for an example of this would be the knee jerk reflex. So you're going to be tapping onto the tendon on the knee exterior muscle, in which that tension that is being applied to that tendon will cause the activation of the muscle fibers to contract. Chapter 2 discusses the 3 different types of levers. So the first one I'll be talking about is first class, which is basically your force, your fulcrum, and then your resistance. In the figure displaying the tricep extension, it demonstrates about how mechanical advantage can play a part into how different levers can operate. So in the tricep extension, it tends to have a more resistance whenever the resistance is up at a 90 degree. So there would be more of an advantage compared to the force in our arm, in our muscle. In the figure, it shows that for the momentum advantage for our muscle is about 5, and then for our resistance momentum is about 40. So what they do is that they divide it, so the 5 divided by 40, which is equals to the 0.125. And in the textbook, it states that if a mechanical advantage is below 1.0, it states that the muscle force has to produce more of a greater force to be able to move the resistance. The second class lever is going to be the force, resistance, and then the fulcrum. So the force and resistance are going to be on the same side. For this would be an example of doing a calf raise. So whenever you're extending your heel off the ground, that is creating the momentum arm. Because of this, the momentum arm compared to the momentum resistance that's going to be in the center, the momentum arm is going to be longer, which will mean that the resistance does not require a lot more. So that's why we're able to load a lot more weight from our calves compared to any part of our body. The third class lever is going to be an example of the bicep curl. So this would be the resistance, the force, and then the fulcrum. So the force and the resistance are just going to be flipped for compared to the second class lever. For this, the bicep curl is a great example because the weight in a bicep curl would be your resistance, your force would be your muscle, and then your elbow would be your fulcrum. The momentum arm in the bicep curl is going to be a lot shorter from the fulcrum to the bicep compared to the fulcrum to the resistance of the weight that you're adding to your hand. Because of this, it requires a lot more resistance or a lot more force for the muscle to have to work compared to a lot more force that the resistance has to create. In figure 2.6 and 2.7, it illustrates how the concept of changing exertion during joint movement is illustrated. So this would be an example of a bicep curl, which it basically demonstrates how in the lower, because of the momentum between whenever your elbow is extended compared to fully flexed, compared to at a 90-degree angle, is the different lengths of the moment arm. Because of the moment arm being a lot shorter during the curl position and during the extended position of the elbow, it requires less force, but compared to your arm being straight or at a 90-degree angle for the curl, the moment arm is going to be at its longest, which is why there is going to be more resistance. This is also another reason why during bicep curls, the hardest part of the curl is going to be right here at this moment where it hits 90 degrees. Because of this, it's also that's why during the curl, the easiest is going to be down below or at the very peak of the curl. Mechanical advantage is able to change across the 3 levers because depending on how close the mechanical advantage is closer to the force or closer to resistance will depend ultimately on how close it is. So for instance, if the mechanical advantage is closer to the force, it would require there would be a higher resistance for the force, creating for instance, it would be a harder curl. Or the mechanical advantage would be opposite, so it would be closer to the resistance, so the curl would be a lot easier of the pull. So for example, a way we could change that is possibly by adding weight to the mechanical advantage by making it harder for the muscle force to be able to produce a higher amount of energy to pull. Chapter 3 goes into discussion about glycolysis, which is the breakdown of carbohydrates, and they could either come from the glycogen stored in the muscles or glucose delivered in from the blood. Glycolysis is a breakdown of multiple enzymes being catalyzed reactions, and this will then turn into ATP resynthesis. The glycolysis system does take a longer time but compared to the phosphagen system, but because of the large amount of glucose and glycogen, it's able to do large amounts of ATP resynthesis. At the end of glycolysis, it turns into pyruvate, and there's 2 ways pyruvate can be converted. It can be converted into lactate into the sarcoplasma, and the second way is pyruvate can be shuttled into the mitochondria. When the pyruvate is converted into lactate, the ATP resynthesis is a lot faster compared to the pyruvate being transported into the mitochondria. During this time that the pyruvate is turning into lactate, it's rapid due to the addition of NAD+. Because of this, it results in a decrease in systolic pH. This is also going to be known as anaerobic glycolysis or fast glycolysis. Although pyruvate being shuttled into the mitochondria is considered the slow glycolysis. This will then undergo the Krebs cycle, which can take a longer duration of time. That's why it's considered aerobic, also known as a slow glycolysis. At higher exercise intensities, pyruvate and NADH will then increase above what the pyruvate dehydrogenase can handle, which will be converted into lactate and NAD+. Because of the 2 different pathways of pyruvate being changed, it is basically determined by how much energy demand is within the cell. So if the energy demand is high, it will be transferred quickly, so then the pyruvate will then turn into lactate. So for instance, this would be an example of doing a resistance training. Another example of it would also be not just resistance training, but also sprinting. Although if the glycolysis and the energy isn't needed that quickly, then the pyruvate will just be oxidized into the mitochondria. So in this scenario, it would be walking, jogging, or doing anything that requires oxygen. But until the oxygen is exceeding and it requires more energy, then it will become an anaerobic workout or exercise. So that would be from walking all the way to sprinting. That would be an example.